In the second part of multi-criteria optimization class, we will discuss about goal programming. Okay, so this part will discuss about uh, what is goal programming, and then we will use one simple examples, and we will provide the graphical interpretation of those examples. And later on, I will also provide a video related on how we can implement the Go programming using a software so-called QM tools. And another one is we can also implement the Go programming using Excel. So yeah, this is the contents of today's materials. This session will support the course outcome that we will expect you to be able to analyze various multi-criteria decision-making methods. Okay, goal programming, a general overview. First of all, goal programming is a form of linear programming. So if you are not familiar with linear programming, I suggest you read books related to operation research. So basically, linear programmings will have like it is a form of mathematical modelings in which you will have decision variables, the objective, and then constraints. And objective or goals in linear programming is normally formulated as a single objective. However, as we are talking about multiple criteria decision making, multiple criteria more optimizations. So in this part, we will first discuss where goal programming will include multiple goals instead of a single objective. Okay, so keywords here, multiple goals. And the idea of goal programming is that uh, an ideal goals we will have an ideal goals to be achieved while also satisfying several hard constraints. Okay, so these goals compose of several objectives that may be conflicting. So, and the main difficulty of the modeling the problems is to find the goals and the soft and hard constraints for these approaches. Okay, we will start from an example provided in the books entitled Introduction to Supply Chain Management from Bernard W. Taylor, published in 2010. So basically, these examples, okay, depict a company, a pottery company, in which we already have initial modelings related to these problems. Later on, we will have again the explanation about this linear programming's implementations. Okay. Okay, and then we will try to rewrite this by considering a new consideration of which we will have this as a goal programming models. Okay, so the problem is like this. The original problem is that we have an objective function z in which it represents a maximization of total profit, and is aiming to be generated by the company by producing or selling uh, total profit by selling their product in the form of bowls, okay, which is x1, and then the number of products in terms of mugs or x2. Okay, Given the information that every bowls that they can, each bowl that they can sell, they will generate $40 of profit, and then $50 of profit for each mug being sold. And then there is a constraint for producing these two particular products, in which the first one is related to the labor, the time available for the labor. Yeah. To produce these products, uh, it is shown that it is requires to produce a bowl, yeah, one bowl, it requires 1 hour of labor. Meanwhile, mugs will requires 2 hours of labor. So here is, should be 1, yeah, x1 plus 2x2, and we will have maximum 40 hours of labor. We will have 40 hours of labor available in a daily basis. Okay, so it will be less than equals to 40. And then the second constraint related to the material being used to produce this product, which is the constraint related to number of clay being used. Okay, and it is shown, or it is known, that each bowl require 4 pounds of clay. Okay, this one 4 pounds, and then it's required 3 pounds of clay to produce the mugs. Okay, and the daily limit for this clay being used is 120 pounds, so it should be less than 120. Okay, the form of the standard linear programming is such, you can see here on the left. Yeah, and it has a single objective for the profit. However, let's suppose that instead of having one objective as the sole objective being considered, the company has listed several objectives in the order of their importance. Okay, so they have four other, yeah, they have four objective instead of only one, like this. Okay, first, the first objective that is important for the company is the labor goal. Okay, why? Because here the reason is to avoid layoff. A company does not want to use fewer than 40 hours of labor. So it's yeah, they don't want to use fewer than the 40 hours. So it should be utilized properly, labor, the working hour of the labor. And then the second one is about the profit. Here we want to maximize profit. However, in this setting, and the new setting, let's say the company would like to achieve, yeah, they have target a satisfactory level, okay, satisfactory profit level of 1,600 per day. So this is like they have a goals of achieving this amount of profit. And then another one is the materials. The clay is limited in the store, so they, to make it not dry out, because every day if you don't use it, it will dry and it cannot be used anymore in the other day. So they want to not keep more than 100,000 pounds on hand every day. So they will have only maximum 120. Yeah, so they want to use less than that one. For the goal is like that, it's treated as a goal. And then the last one is about overtime goals. Yeah, because overhead cost is quite high, so the company want the result or the decision will give the company a decision that have the minimum amount of overtime. Okay, So how do we reprogram this one as a goal program? Okay, we will see it one by one. Okay, now we will start to accommodate one by one each goal that is being stated by the company. We will first by discussing the first and the fourth goal, in which it is um, the labor goal and then the overtime goal. Labor goal is about avoiding layoff, so that the company does not want to use fewer than 40 hours labor per day. Overtime goals actually related with this one, but we consider the overhead cost or overtime. Now we want to minimize the overtime. Okay, all these labor hours is actually embedded in this constraint, right? X1 plus 2x2 less than equals 40, in which if we are going to make it into a goal programming approach, we need to um, translate this constraint into a goal constraint. So they will update it to the uh, objective function later. Okay, how do we convert this one into the goal constraint? First is we would like to see how we can convert these inequalities to equalities. Okay, so goal constraints, okay, here. Goal constraints are equalities that will include something that we call deviational variables, or here represent with d minus and d plus. It will represent what? D minus is a positive deviational variables which represent the amount by which a goal level is exceeded. Okay, so for example here they want a 40 labor, the goals, yeah. uh, D plus will represent if we utilize more than 40 hours, so D plus will have value. Okay, exceed than 40 hours. And then negative deviational variables D minus is represent the amount by which a goal level is underachieved. For example, if we use only 30 hours, so the D minus will have value. For example, like what? If you produce x1, let's say x1 is the number of bowl you produce equal to 5, okay? Then the number of mugs you decide to produce in the amount of 10. So here you will have 5 plus 20, yeah, 2 multiplied by 10 plus d1 minus d1 plus equal 40. So in this one we will decide based on the objective what do we want to do with d minus and d plus here for d1. Okay, here 30, 25. So it means that the amount of this one is underutilized than 40, right? So d1 minus, so it means that the deviation of variable in which the goal is underachieved will have value of 15 to make up become 40. Okay, because 25 plus 15 will be equal 40, and d1 plus will be equal to 0. Why? Because we want to minimize d1 minus and also d1 plus. Okay, yeah, to minimize that value. Yeah, because if you have more on the d1 plus, it will not achieve this one, right? And then the value of d1 minus and d1 plus cannot be negative. Okay, so the objective of function in a Go programming model is seek to minimize the deviational from the goals in order the goal priority. So you have this priority then this priority, and then you will try to minimize the deviational, and the value of d1 minus and d1 plus is cannot be equals to 0. It cannot be less than 0. I mean, yeah, should be greater than equal to 3. Okay, now then you will plot this um, new objective function, yeah, new objective function to the linear programming, which we already start considering the first and the fourth goal constraint in this goal programming approach. Okay, remember we still have two more goals, and we will try to formulate it one by one again after this. Okay, now we move on to the second goal, where we have the profit goal. It is stated before that the company would like to achieve satisfactory profit level in the amount of 1,600 US dollar per day. So the constraint that will relate to this one, to make up this constraint, is the constraint related to the objective itself. Okay, we will convert it into a goal constraint. Remember, goal constraint will consists of equalities that include deviation of variables. Okay, so you have for a goal of profit, it represent by 40 multiplied by number of bowl produced, 50 multiplied by number of mugs produced, and then this is the deviation from the goal. D2 minus, yeah, it's a new variables, represent how much it is under 1,600, and then D2 plus how much this is exceed the profit goals. Okay, for this one, of course, we don't want to minimize the exceed 1,600. We want it, if it is possible, we will exceed it as much as possible. So what do we want to minimize here is the one that is under, yeah. So it will be minimized P1 multiplied by D1, priority 2 multiplied by D2 minus, yeah, and P4 multiplied by D1 plus. This is from the previous explanation. And then this will be plugged into the new objective functions. Okay, remember this will already be changed. Yeah, this changed to the new constraints that mentioned earlier. And then we will still have one more goals need to be considered. Okay. Okay, the last goals is so-called materials goals, where we will have the materials in which the clay that must be stored in a special place in the factory so they will not dry out. The company will like to keep not to keep more than 120 pounds. So again, the constraint that relate to this goal is this one, and we will modify it into a goal constraint. Yeah, become for x1 plus 3x2 plus d3 minus. This is under the limit of 120, and then this one is exceed the limit of 120. Of course, we want to minimize this one. We don't want to exceed than 120, right? So it becomes d1 p1 d1 minus p2 d2 minus, and then p3 d3 plus the one that we minimize this time, and then this one also from the previous one. Okay, this will plug here, and then this will change the new constraint. Okay, finally we will have the new goal programming formulation, in which we will have all the goal constraint here related to the I forgot, this is the labor goals, this is the profit, this is the material use, this is the overtime. Okay, goals number 1, 2, priority 1, priority 2, 3, and then 4. Okay, and you can see that here the term in the minimize function here is not being summed. Okay, not plus p2 d2, no, because the objective function itself represents the definition of variables that might have the different unit of measure. Okay, for example, this one in terms of labor hours, yeah, this one in terms of US dollar because it's the profit, and this one is a number of uh, uh, materials in pound, and this one in terms of the labor hour as well because it's the overtime. Yeah, so you can see here the constraint 1, 2, and 3 all is modified to adapt with the new goal programming constraint. Okay, and you can solve this one using solver in Excel or QM tools. Later we will introduce. But now we will move to the illustration, graphical illustration of this new formulation. Okay, uh, the solution logic in Go programming is to attempt and achieve the goals in the objective function here, right? In order of their priority 1, 2, 3, and 4. And as the goals is achieved, the next highest ranking goal is then considered. So you consider priority 1 first, and then 2, and then 3, and then 4. So the graphical illustration will illustrate how the goal programming solution logic seeks to achieve the goal by minimizing the deviation. Okay. So first you need to plot. Yeah, if you want to use the graphical illustration you need to plot all the line related to this one, right? All this constraint. Okay, so you will have 3 lines. The first line is this one to represent the materials used. This one is for the labor hour, and this one is for the profit. Okay, first let's illustrate the first priority goal, which we want to minimize D1 minus. It is the represent the amount of value, deviation of value, the labor hour is less than 40. Okay, so the corresponding line is this one, right? The third line here. Okay, and if you check the area representing a D1 minus and D1 plus, it will be look like this. Okay, the area below the line, yeah, will represent D1 minus, and then above the line will represent D1 plus. Okay, and in order to achieve the goal, which we want to minimize D1 minus, so the area of D1 minus, this one should not be considered anymore, so should be eliminated. Okay, so it will lead the shading area here as the possible solution area for this goal of programming. Okay, and then we will move to we have no conclusion yet here. And then we need to, because we need to consider several other priority goals. And then based on the last priority goals being solved already, we move to the second priority goal, in which we want to minimize D2 minus, yeah, which like it will relate it to the profit, where D2 minus represent how much profit will be under 1,600, deviation of profit to the 1,600, yeah, less than 1,600. And so here you have the previous shaded area, and then you need to consider the second line here, yeah, here, and as you can see that the area above here represent the variable of D2 plus, and then in the area below the line represent the area of D2 minus. So what are you going to achieve here is the goal of minimizing D2 minus. Therefore, as similar with the previous approach, the area related to the D2 minus will be eliminated, and then it left the shaded area combined with the previous one above the line combined with the previous one. Okay, so this is the new shaded area. Then we move to the third priority goal. Okay, the third priority goal here, as you can see, it's corresponding to the this line, right? The this line, and then it's a little bit different where you want to minimize D3 plus. Okay, previously all we minimize is D minus part of it, and then now it's D3 plus. So from the line, we need to check which area belong to D3 plus up there, right? Which previously being shaded. Then now the one that is belong to D3 minus is this one. We are not eliminating D3 minus because the goal is to achieve minimization of D3 plus. So here, so we need to eliminate all the one that belong to D3 plus here. Yeah, this is eliminated. Okay, and leaving the shaded area as the possible solution area. Okay, you can see here is the one that the area that left. Next is the last goal, which is the minimize D4 plus D1 plus. Okay. Finally, we would like to minimize the fourth goal, which is minimize D1 plus. And we know that with the similar manner, the goal constraints line x1 plus 2x2, x in which is this one, we will represent this goal, and then d1 plus is this area right above this line. But if we delete this, yeah, we want to we have the goal to minimizing the d1 plus, so area corresponding to d1 plus is going to be eliminated. However, if we eliminate this area, okay, if we eliminate this area, then the both d1 d2 minus, and we know that both d2 minus and d2 d3 minus need to take value because their priority is higher than the d1 plus to be deleted. Okay, so we cannot minimize d1 plus totally without violating the first and then the second priority goals. Okay, I mean like the second and the third priority goal. So we will like to build a solutions that satisfy the first three goals. We will not consider the fourth goals. Okay, the fourth priority goals will be uh, consider if the first, second, and then the third is can be achieved already, something like that. So here, based on the shaded area that we have previously, we have the choice of using A, B, and C, and we can see that the value, the point that minimize the or that satisfy all those functions in the minimum manner is point C, which the x1 equals 15 and x2 equal 20. If you go down again here, you see that it is going to violate one of the constraint or one of the priority here. So we decide to select C as the solution for this goal programming. Okay, regarding the use of goal programming, the implementation of goal programming using QM tools, I will provide the tutorials later. Also, the uh, utilization of Excel software to implement the goal programming. Yeah, it's also going to be provided later. So I think that's all for this slide. Thank you very much.